using integration to find the area under a curve. So here's how we'll start out. We'll start out by saying that the area of the region bounded by the curve y is equal to f of x, the line x is equal to a, x is equal to b, and the x-axis is given by the formula, or is given by area is equal to the integral from a to b of f of x dx. All right, now the area that we're talking about is illustrated in the diagram to the right. First of all, this area is bounded by the curve, the x-axis, and the line x is equal to a, and the line x is equal to b. The region that we're talking about is the region that is shaded blue. That region is bounded by the curve y is equal to f of x, the x-axis, the lines x is equal to a, and x is equal to b. And that area, the area of that region is given by the formula. The area is equal to the integral of f of x from a to b, and of course you're integrating with respect to x. So let's have a look at example 5. Now, example 5 says, find the area of the region bounded by the curve y is equal to x squared, the line x is equal to 1, x is equal to 2, and the x-axis. All right, I would say as a rule, whenever you're doing a question, one of these questions, it's good to draw a sketch of the curve. All right, so I'm just going to do a basic sketch. Of course, y is equal to x squared is a familiar curve. It's symmetrical about the y-axis, and of course, it does not fall below the x-axis. All right, it stops at the x-axis. That's my y. All right, and then I do my little curve. It's a parabola. All right, so this could be, it's a sketch of the curve. Y is equal to x squared for values of x greater than 0. All right, this could be like x is equal to 1. And this could be x is equal to 2. So the region we're talking about is this region here. Now, of course, we're told that that area, the area that is bounded by the curve, the x-axis, x is equal to 1 and x equal to 2, is equal to the integral from 1 to 2 of y dx, which is equal to, let's continue it over here, which is equal to the integral from 1 to 2 x squared dx. Of course, when you integrate x squared, you're going to get increase the power by 1, so it's x cubed divided by the new power 3. And of course, this is within the limits 1 to 2. All right, so replace x with 2. We're going to get, this is x, replace x with 2. We're going to get 2 cubed over 3, minus replace x with 1, 1 cubed over 3. So this is going to be, so we made an error here, this should be 3. This is going to be 8 over 3 minus 1 over 3, which is equal to 7 over 3. And because you're finding area, this is square units. All right, so the area under the curve y is equal to x squared, from x is bounded by the lines x is equal to 1, x is equal to 2, and the y-axis, that area is 7 over 3 square units. Let's have a look at another question. All right, example 6 says find the area of the region bounded by the curve y is equal to 1 over 2x plus 1 cube, the line x is equal to 1 and x is equal to 3. All right, so let's try and do a little sketch. This is the y-axis. All right, and this is like the x-axis. All right, so if I start by saying we have y is equal to 1, I'm just doing a little sketch, so it's 2x plus 1 cubed. I could say when x is equal to 1, when x is equal to 0, y would be equal to 1 over 2 times 0 plus 1 cubed, which is equal to 1 over 1, which is 1. So of course the point 0, 1, the curve passes through 0, 1. So let's just say that this is 0, 1. When x is equal to 1, y would be equal to 1 over 2 times 1 plus 1 cubed, which is equal to 1 over 3 cubed, which is equal to 1 over 27. All right, so this is 1, let's say 2, and let's say 3. All right, so of course for this graph, the x-axis is an asymptote, meaning that the curve approaches the x-axis, but it never ever touches it. All right, so my curve could look something like this. And of course, as x increases, the value of y decreases. All right, so we want the region between here, x is equal to 1 and x is equal to 3. So this is the region we're talking about. And of course, this is just a sketch, all right, x-axis. And we could say that this area is equal to the integral from 1 to 3 of y with respect to x, which is equal to the integral from 1 to 3 of y, which is 1 over 2x plus 1 cubed dx, and this would be equal to the integral from 1 to 3 of 2x plus 1 to the minus 3 dx. Now, if I integrate this, I'm going to increase the power by 1. So this is 2x plus 1. This is a linear factor. Increase the power by 1, it becomes minus 2. And of course, I have to divide by the new power, so that's minus 2. And we also have to divide by the differential of the inside function. All right, so the inside function is 2x plus 1. When you differentiate that, you're going to get 2. And all of this now is within the limits 1 to 3. All right, we can pull out the 1 over 4. So this is minus 1 over 4. All right, and this becomes 1 over 2x plus 1 squared, and this is within the limits 1 to 3. All right, let's continue over here. So we could say that this area would be equal to minus a quarter. You're going to replace x with 3 and then replace x with 1. So it's 1 over a quarter, and you're going to have 1 over 2 times 3 plus 1 squared. You replace x with 2 or with 3, minus replace x with 1, so it's 1 over 2 times 1 plus 1 squared. So this becomes minus a quarter, 1 over 2, 3, 6, and 1, 7, so that's 7 squared, minus 2 ones, 2, and 1, 3. So this becomes minus 1 over 4, 1 over 49 minus 1 over 9. The LCM is 49 times 9. 49 goes into that 9 times. 9 times 1 is 9. 9 into this goes 49 times. 49 times 1 is 49. And so this area is equal to minus 1 over 4 times minus 9 minus 49 is minus 40. And 4 times 9, I believe, is 441. 4 into this 1, 4 into this is 10. A negative times a negative is a positive. So our final answer is positive 10 over 4, 4, 1. And of course, because you're finding area, it is square units. All right, let's have a look at the next question. All right, example says, the diagram shows part of the curve y is equal to sine 2x. We're to find the area of the shaded region. So, so the shaded region is bounded by, is the area that is bounded by the curve. The line x is equal to 0, and the line x is equal to pi by 4, and the x-axis. All right, and as we already said, that this area is equal to the integral from 0 to pi by 4 of y dx. So this area, so this would be equal to 0 to pi by 4 of sine 2x dx. Now, whenever I differentiate cos, we get minus sine. So if I integrate sine, I'm going to get minus cos. So this is minus cosine 2x. And of course, you have to divide by the differential of the inside function, which is 2. And the limits are 0 to pi by 4. So next, we can pull out the minus a half. So we have minus a half here. Then we're going to replace, so inside we're going to have cos. Inside we're going to have cos 2x 0 pi by 4. So next we're going to replace x with pi by 4. So this is equal to minus a half the cosine of 2 times pi by 4 minus, and replace x with 0, the cosine of 2 times 0. So this becomes minus a half, and then this is the cosine of pi by 2 minus the cosine of 0. The cosine of pi by 2 is 0. The cosine of 0 is 1. So what we have is minus a half multiplied by minus 1. And negative times a negative is a positive, a half. So the answer is a positive a half square units. All right. So again, the area bounded by the curve y is equal to x, the lines x is equal to a, x is equal to b, and the x-axis is equal to the integral from a to b of f of x, and of course you're integrating with respect to x.